All right, today we're diving into the fascinating origins of machine learning, all about how we first started teaching machines to recognize patterns. Way back in the early days of computing, someone asked this totally wild question, a question that literally changed everything. Could a machine do more than just, crunch numbers? Could it actually learn?
I mean, really let that sink in. Can a machine learn patterns all by itself? Not just to follow a pre-written list of commands, but to actually see something and learn from it. That was the huge, kind of mind-blowing idea that early researchers were wrestling with. And believe me, it was a puzzle that would take a long time to even begin to crack.
So, if you look back to the 1950s, computers were these massive mainframes. They were absolute beasts at doing math, but they weren't smart, not in any way we'd recognize today. They were powerful for sure, but incredibly rigid. Every single thing they did had to be explicitly programmed by a person, line by tedious line of code. They only followed instructions, period. Now, let's just jump forward to today. Your phone automatically finds and tags your friends in your photos, right? Music apps recommend a new song that you instantly love. That's because today, our machines learn from experience. It's a night and day difference. So the big question is, how on earth did we get from those clunky, rule-following giants to the smart devices we have in our pockets? Well, it all started with a totally new way of thinking. It was this huge conceptual leap, a move away from telling a machine exactly what to do and toward letting it figure things out for itself, a shift from rigid rules to flexible learning. So there were basically two ways to solve a problem. The old way was what we call rule-based systems. You'd have a programmer sitting there typing out endless if-then rules. If the email has this word, then mark it as spam. It was super tedious. But machine learning, it flipped that whole idea on its head. The thinking was, hey, what if we stopped feeding it rules and just show it a ton of examples? Let the machine discover the patterns on its own. Here's a super simple way to visualize this. Imagine you've got this graph with a bunch of red and blue dots scattered all over it. The goal is to draw a line that separates them. Now, the old way would be a human trying to figure out the exact mathematical formula for that line, but the machine learning approach asks a much more interesting question. Can the machine just find a good line without us telling it how? And this is where it gets really cool. This is how a machine starts to think. First, it just takes a guess. It draws a line randomly. Then it checks its work. Whoops, I got 20 dots on the wrong side. So it nudges the line a little bit and tries again. Okay, now only 15 are wrong. It just keeps doing this over and over and over. Draw, count mistakes, adjust, repeat. It keeps going until it finds a line that does a pretty good job. It's literally learning from trial and error. Now, separating dots on a graph is one thing, right? But one of the very first and most famous real-world examples show just how incredibly powerful this new idea of learning could be. And it all started with a simple game of checkers. That's right, a checkers-playing computer. Way back in the 1950s, an IBM pioneer named Arthur Samuel decided to teach a computer how to play. But, and this is the absolute genius part, he didn't program it with a playbook of specific moves. Instead, he programs it with the ability to learn which board positions were more likely to lead to a win. How did it learn? He just had it play thousands upon thousands of games against itself. With every single game, it got a tiny bit smarter, adjusting its strategy, and then something incredible happened. The program got so good that it actually became a better checkers player than Arthur Samuel himself. This was a huge deal. For the first time, a machine had surpassed its creator at a complex task, simply by learning on its own. This groundbreaking approach, this whole idea of learning from examples where you already know the right answer, now has a formal name. And it is one of the absolute cornerstones of modern AI. It's called supervised learning. The best way to think of it is like teaching a student with a set of flashcards. The programmer, who is kind of like the supervisor or teacher, gives the machine a massive data set where all the answers are already labeled. The machine's job isn't to guess the answer, but to figure out the underlying patterns that connect the problem to the correct solution. So, for instance, we might feed it a million pictures, and each one is neatly labeled, "This is a cat," or "This is a dog." Or we show it a huge pile of emails, each marked spam or not spam. By analyzing all this labeled data, the algorithm starts to recognize the patterns by itself. It figures out what features, like pointy ears and whiskers, tend to show up in cat pictures. But as mind-blowing as these early successes were, We have to remember that the pioneers of this field were basically trying to build a rocket ship with stone tools. They were working against some truly massive constraints. To put it in perspective, just look at the raw computing power they had back then versus what we have now. The power of a 1960s computer is a tiny, tiny fraction of what a single modern graphics card can do. We're talking a performance gap that's millions, maybe even billions of times bigger. It's not even in the same ballpark. And it wasn't just the slow processors. Think about all the other hurdles. Finding large sets of data was incredibly difficult and expensive. And then, where would you even store it? Storage was so limited that just a few megabytes of data could take up an entire room. These physical limitations meant that even the most brilliant algorithms could only do so much. So you might be wondering, okay, if it was so limited back then, why do we look back on this era as being so important? Well, the reason it still matters so much is because the foundational ideas they came up with are what everything else in AI is built on today. They planted the seed. You can really see it on this timeline. The 1940s gave us the theories. Then the 50s, with things like the checkers program, showed that these theories were actually possible in the real world. And by the 60s, researchers were developing the core algorithms. This whole period was the foundational era that made everything that came after possible. Because here's the key takeaway, the most important part of all of this. What they proved was that the most powerful way to build intelligent systems wasn't to have humans write all the rules. No, it was to build machines that could learn the rules for themselves from data. That single, crucial shift in perspective changed absolutely everything. But of course, this leads to an even bigger question. It's one thing to learn how to draw a simple line between some dots. It's another to master checkers. But what about really complex patterns, like recognizing any object in a photo or understanding human language? How could a machine possibly learn patterns that weren't so simple? Well, to solve that, researchers needed a new inspiration. The most powerful learning machine we know of, the human brain. And that is exactly what we're going to explore in our next explainer. We'll dive into the story of the perceptron, one of the very first attempts to build an artificial brain cell. You are not going to want to miss it. Hey, thank you so much for watching. We're Knowledge Equity Partners. And as a multilingual channel, we're all about sharing contemporary and practical knowledge on all sorts of topics that can help make your daily life just a bit more effective and efficient. If you found this valuable, and we really hope you did, please subscribe to Knowledge Equity Partners so you get notified about all our daily videos. And of course, don't forget to like, share, and spread this practical knowledge with your family, friends, and your whole community. And definitely be sure to look out for our next episode for more on this fascinating journey. Until then, let's together keep the quest for knowledge always high.